So in this last part about Lewis electron dot structures, we're going to talk about exceptions to the octet rule. So there are three types of exceptions. First of all, there are ones with an expanded octet, more than 8 electrons. There are a few with odd electrons, and then there are very few that have less than 8 electrons. We're going to look at them in an odd order since all of these are fairly odd. We're going to look at number 2 first. Let's look at the number of odd electron species. This should have a 2 next to it because it's the odd ones. There are only a few that have odd numbers of electrons in the world. These are 4 of them. They end up having 1 extra electron, and therefore 1 extra has to go on 1 atom. There's no specific rule to these, and they're simply frustrating. Here's one example of NO. It can be drawn this way with 1 unshared electron here on N, or it can be drawn this way with the 1 unshared electron on the O. You'll probably never encounter odd electrons again, but now you've seen them. The second exception, and this one you might see again, is for things that have less than 8 electrons. Less than 8 electrons frequently occur, first of all, with hydrogen and helium. These are actually the number 1 exceptions, and you see those a lot because hydrogen, of course, only wants 2 electrons and only forms 1 bond, and helium, of course, has 2 electrons only, and it's a noble gas, so it never changes. But the ones that you see it the most in that are weird exceptions are in boron and beryllium. Boron and beryllium right here. Those are the 2 that will form some structures that have less than 8 electrons. So here's BF3, and if you draw the Lewis electron dot structure for that, boron has 3 valence electrons, fluorine has 7 times 3, that's 21 or 24. So take the boron and put it in the center. You can see boron has 3 right here in group 13. Fluorine has 7 because it's in 17. Bond the other electrons around it, or bond the other atoms around it. 1, 2, 3 gives us 6 electrons, so 24 minus 6 gives us 18 electrons left. So 2, 4, 6, 8, 10, 12, 14, 16, 18. There's the Lewis electron dot structure. Boron only has 2, 4, 6 around it. Turns out that boron can do this. Boron can do this. When we get to chapter 16, maybe into 17, we'll use BF3 as an example of an electron acceptor, and we'll talk about how it can be one of the weird exceptions in a Lewis type of acid and base reaction. For right now, just remember boron and beryllium, and you probably will not see one like that again. Not for a long time. The place that you will see the exception is where there's more than 8. These are called expanded octet or hypervalent molecules. Hypervalent, hyper meaning more, so more than a valence of 8. P of 5 is an example. So P, 5 fluorines around it. We have no choice. We have to put 5 fluorines around the phosphorus. Phosphorus ends up with 2, 4, 6, 8, 10 electrons around it. Well, that's not legal because you're really only supposed to have 8. But it turns out that if you are in the 3rd period or below and you're a nonmetal, you can break that rule sometimes. 3rd period or below. 3rd period or below. Why is that? Well, it's believed that period 3 atoms and below have a larger size. Well, it's known that they have a larger size than period 2. And since they have the larger size, they have more room for extra electrons. These guys in period 2 right here never, ever, ever will have a hypervalency. They won't ever have an expanded octet to them. Here are a couple of examples. SF4, ASF6-, ICL4-. Those are ones that end up being hypervalent and having an expanded octet. I'll do one example for you of drawing an expanded octet molecule. This is XEF2. I'll draw it over here because I have more space. XEF2. Add them up on the periodic table first. Xenon, of course, rarely forms molecules, but in this case it does. It's got 8 electrons. plus fluorine, the Tyrannosaurus rex of the electrons elements, and it's probably the only thing that can form a bond with xenon because it's so good at eating electrons. 7 valence electrons times 2, so 14 plus 8. Let's see, that would put us at 22 valence electrons. Put the least electronegative in the middle, put fluorine right here, put fluorine right here, 2, 4, 22 minus 4, that's 18 electrons left. Now if I go 2, 4, 6, 8, 10, 12 around there, 18 minus 12 leaves me with 6 electrons left. That's pretty close. 2, 4, where do I put it? Put the extra electrons on the central atom, and now the central atom has an expanded octet, as long as it's 3rd period or below. Is xenon 3rd period or below? You bet. And so we can go ahead and have an expanded octet on that xenon difluoride. So, 3 exceptions: odd, less than 8, more than 8, hypervalent animals. Good luck with your Lewis dot structures.